How did suspension bridge engineers innovate world firsts? Imagine crossing a river or a deep canyon with a bridge that seems to float in the air. That feeling of awe comes from the incredible work of engineers who pushed the limits of what bridges could do. They didn't just build bridges. They created new ways to stretch the boundaries of engineering and reach places once thought impossible. The story begins with simple rope and vine structures used by the Inca civilization in the 1400s. These early bridges were made from woven grass and replaced every year. They showed how humans could use limited materials to connect difficult terrain. Fast forward to the 1800s, when the first modern suspension bridge was patented by James Finley in 1808. His design used iron chains to hold up a deck, which was a huge step forward. The Jacobs Creek Bridge in Pennsylvania, built in 1801, was one of the first to use this system, setting the stage for future innovations. Thomas Telford's Menai Bridge, finished in 1826, was a major leap. It used iron chains and a stiffened deck to span 579 feet across the Menai Strait in Wales. This bridge could support heavy loads and was very stable, proving that large-scale suspension bridges could be built successfully. Then came John Roebling, who in the 1930s developed wire cables made of many strands. This was a big improvement over the earlier chains, making bridges stronger and more durable. He also invented a way to spin the cables on site, saving time and money, and designed decks stiffened with trusses to better handle loads. A key breakthrough came with Joseph Mellin's deflection theory, published in 1888. It explained how the deck and cables bend together under load, allowing engineers to design longer spans with lighter, more elegant structures. This theory helped build famous bridges like the Williamsburg Bridge in 1903 and the Manhattan Bridge in 1909, which had steel towers and truss decks. Joseph Strauss's design for the Golden Gate Bridge in the 1920s was a mix of suspension spans and truss structures. Engineers used slide rules and detailed drawings to perform complex calculations without computers. The result was an iconic bridge that could handle heavy traffic and span 2,737 meters. Later, the George Washington Bridge, designed by O.H. Ammon, set a record with a span of 1,050 meters or 3,500 feet. It used advanced steel cables and aerodynamic shapes to push the limits of what was possible at the time. These innovations made it possible to build longer, safer, and more beautiful suspension bridges. They allowed humans to cross natural obstacles that once seemed insurmountable, opening new routes for trade and travel. All these advances in materials, design, and construction techniques helped engineers create bridges that are not only functional but also works of art. They showed that with clever ideas and careful planning, humans can reach beyond their limits and achieve incredible feats of engineering.